First of all, it is a pleasure to be with you all at this international conference, and I'd like to thank Dr. Inam for his invitation. It's been very, very meaningful for me. I'm Soufiane, doctoral researcher at Inam Computer Science and in the University of Electrical Engineering at ICETI University at Morocco. My research focus on the exciting new frontier of flipped classroom models using the innovative Spoke means smart private online course, as well as distance learning design and implementation for sure. My academic prowess extends to the design and the implementation of distance learning, a field in which I aim to innovate. In this presentation, we will talk about learning from software engineering and its influence on instructional design. So we will explore how the principles of and practice of software engineering can inspire the design of engaging and effective learning activities. So in this presentation, I will explore the four type of script and online learning and their significance in instructional design. I will also draw parallels between instructional design and software engineering process. Additionally, I will introduce visual modeling language that can effectively represent different aspects of instructional design. By discussing various views, the presentation aims to provide a comprehensive understanding of the instructional design process. Lastly, we will delve into the potential application of existing software engineering diagrams and models in instructional design. So, the lack of success in many instructional design endeavor is frequently attributed to an inadequate instructional design practice. Existing instructional design models offer limited guidance on designing a learning instructional solution. It is possible that current pedagogical design models do not adequately cater to the need of online learners. One potential gap lies in the insufficient consideration of the unique characteristic of online learning. Traditional models may not fully acknowledge the disparities between classroom and online classroom, which can result in less than optimal outcomes. Moreover, the absence of clear framework can lead to disorganization and inconsistency in online courses, causing confusion and frustration. To address these gaps, customized pedagogical plans are necessary for online learning scenarios, taking into account the different factors such as technology integration, learner engagement, and interactivity. The importance of clear presentation and structured organization cannot be overstated. Speaking of which, within the four types of scripts in online learning situation lies the revelation of this script. This framework outlines four distinct stages and their corresponding activities. The first is situation where content is presented and the diagnostic evaluation are conducted. A remedial stage is also provided. Next step is conceptualization stage where learners engage in tasks such as explaining concepts utilizing two different approaches, deductive or inductive approach, and for sure organization those information. The first phase is objectivation, encompass group discussion, practical application of knowledge, and continuous assessment, forming the core activities of this stage. Finally, the transfer phase, a pivotal stage in this pedagogical framework, is reached when this phase involves in-depth analysis of case studies and comprehensive summative assessment, serving as crucial component in evaluating overall learning outcomes. This phase sets the stage for the application of acquiring knowledge and the development of practical competencies. Now that we have discussed this four type of scripts in online learning situation for sure, let's explore the similarities between the field of software engineering and instructional design. So by understanding this connection, we can uncover valuable insights that can enhance our approach to instructional design. While structural design and software engineering may seem like distinct fields, they share some fundamental and process. Both disciplines aim to create a full, a well-structured and effective system that can deliver a desired outcomes. In fact, conceptual design can benefit greatly from adopting some of the proven practice and methodology of software engineering. First of all, we start with the first phase is analysis. So both field involve analyzing the needs or and the requirement of the end user of or learners. This analysis phase help in identifying the goals, objectives, and constraints of the project. For the second explorative found that the designer and software engineer creates blueprints or prototype before moving to the third phase, which is development. So this phase they focus on creating effective and user-friendly solution. For the development both fields involve the development of the final products. So while the instructional design creates learning materials like courses or models. So for the testing phase, the both field while software engineering emphasizes the importance of testing and quality assurance, structural design conducts formative and summative evaluation to ensure the effectiveness of the learning materials. While software engineering perform various testing techniques to identify and fix bugs and errors. For the iterative process, the both field follow an iterative process. They continuously gather feedback, might make improvements, and refine their product based on user feedback and the changing requirements. For the final similarity, we found that collaboration required collaboration and teamwork. While instructional design often work with the subject matter experts, design and multimedia developers, software engineering collaborate with other developer, tester, and stakeholders to build and deliver high-quality software solution. Now that we understand the similarities between the two fields, let's ask ourselves what technique or language from software engineer are we using in this domain? Well, the language we use to design our activities is UML. It's a standardized visual modeling language used in software engineering to design, visualize, and document systems. It provides a set of graphical notation for representing various aspects of system, including its structure, behavior, and interaction. It offers different view to represent offer different view to represent different aspects of a system, including static and dynamic view. For static view, also known as the structural view, focus on the structure and composition of the system. It represents it represents system static entities such as class, objects, interfaces, component, package, and relationship between them. UML diagram commonly used to model static view include the class diagram and use case diagram. While the dynamic view, also known to the behavior view, centers its attention on the dynamic behavior of the system and the collaboration efforts among its entities. It portrays the progression of execution, interaction, and alteration in the system state as time unfolds. Notable UML diagram employed to depict the dynamic view encompass the sequence diagram and activity diagram. The class diagram is one of the most widely used diagram used in the static view. So in UML, it shows the different classes, their attributes, operation, and relationship between the classes, such association, aggregation, and composition. A class is represented by a rectangle divided in three parts. The first part contains the class name, while the second contains the class attribute, while the last contains the class method. The line that you see that link the class is an association. It is a semantic connection between two classes. An association can be named. So in this example, the name of this association is guide. For the numbers that you see in the screen, we call them cardinalities. They are used to specify the relationship between classes, indicating how many objects of one class are associated with a certain number of objects of another class. Cardinality are represented by numbers or symbols placed near the association line between classes. When it comes to interpreting the first association in terms of reading, it can be stated that one teacher has the ability to guide either one or more or many or multiple learners. And same applies in reverse. The sample of stars is used to present the concept of many. The use case diagram is used to model interaction between actors, focusing on the functionalities offered from the user point of view. Displayed on this screen is a diagram illustrating a collection of 5 use cases. The include use case is obligatory and cannot be forgotten when executing the basic use case. In this case, the work must be sent to the teacher before the presentation. In the other flip, the extension allows to model alternative scenarios or optional functionalities that can be activated according to specific conditions. The extend use case is optional and it is not executed every time the base use case is executed. This scenario means that the learner may ask for help if desired or not, and it is not as included. For the dynamic view, perform making them ideal for illustration control and data flow. As a result, they provide a graphical representation of the behavior of a method or progress of a use case. An activity diagram will begin with the activity diagram. This symbolizes the beginning of the activity. It is represented by a black circle. This rectangle indicates the activity that make up a model process. These symbols, which include a description in the form, are the main component of an activity diagram. The decision symbol represents a decision and always has had at least two branches with condition text to allow user to see the option. This symbol represents the branching or merging of different streams and serve as a frame or container. The final note is represented by an outlined black circle. For the arrow that you see, for the arrow that you see indicated the direction flow or control flow of the activity, and an incoming arrow marks the start of an activity step. Once the step is completed, the flow continues with the outgoing arrow. A sequence diagram is a type of human diagram that shows the sequence of interaction between systems in a specific scenario. It emphasizes the chronological order of message exchanged between objects during the execution of feature or process. An actor represents an external entity that interacts with the other actor in question. It is usually represented by a block shape or human silhouette. The lifeline represents the existence of an object over time. It is represented by a vertical dotted line extending vertically from the objects in the sequence diagram. The message represents communication between objects and actors. They indicate method calls or information exchange between participants. The messages are represented by an arrow with a label indicating the name, argument, and return value. It exists many types of messages, and the most used are synchronous and asynchronous. The synchronous is represented by a solid line terminated by a solid arrowhead. This sample is used when a sender must wait for a reply to reply to a message before continuing. So it shows both the call and the response. In the other flip, the asynchronous one is represented by a solid line terminated by arrowhead. Asynchronous not require a response before the sender continues. For the conclusion of this presentation, the integration of software engineer design principles into a structural design with the use of human diagram have acted as a visual depiction of the structural design process. Heightening understanding of communication, the adoption of human has simplified the implementation of software engineering principles such as modularity, usability, and scalability. It is indeed true that having a deep understanding of the use of human is necessary for its effective application in our structural design. So in this voice diagram, there are still numerous aspects to left to explore and uncover for sure. Ultimately, there's so much more to be discovered. These are some references used in this presentation. Thank you all for having me on this conference, and I hope we can see each other in the next, maybe in the next conference. So until then, see you all in peace.